Next up, we have the quotient rule. Quotient rule is used when you have fractions. Again, just like before, sometimes you may be able to rewrite it and avoid the rule altogether. That is the case for part A, not necessarily the case for parts B and C just yet anyways. We'll need some more rules underneath our belt if we wanted to rewrite B and C. Let's do part A. So part A, here the 5 is high and the x squared is low. So according to the quotient rule, it's sing your song, low times the derivative of high, low-d high, minus high times the derivative of low, high-d low, all over low squared. Low-d high minus high-d low, all over low squared. All right, just putting in primes as necessary. So writing it out with primes, we're going to have low times the derivative of high minus high times the derivative of low all over low squared. Just like before, if you want to go right to it, go right ahead. Not just yet. Okay. So we're going to have x squared times the derivative of 5, which is 0, minus 5 times the derivative of x squared, which is 2x, all over x squared squared is x to the 4th. Well, what is 0 minus x squared? 0, so that term's gone. And negative 5 times 2x, be careful on the negative sometimes, especially if you're multiplying it through by a binomial, is just 10x over x to the 4th. Well, notice you have 1x upstairs, 4x's downstairs, so you're going to lose 1 in each case, so you'll have negative 10 over x cubed. Now, we could have gotten that a lot faster and avoided the quotient rule if we brought that x squared upstairs as a negative 2. So notice you multiply the 5 times the negative 2, make you negative 10, take 1 off your exponent, which would make it a negative 3, and then if you brought that downstairs, it would be a positive x cubed. Hooray! Let's try another one. We're going dark green. B. So again, here's high, here's low. Nice to meet you. So according to the derivative, again using primes, be low times the derivative of high minus high times the derivative of low all over low squared. Okay. If you would, take a second and find your derivatives. All right, that's all the time I'm giving you. So it's low, x plus 9. What's the derivative of x plus 1? It's just 1 minus high, x plus 1 times the derivative of low. Also just 1 all over low squared. Now while we're here, let me ask a quick question. Can I cancel out an x plus 9? Let me highlight it so you know what I'm talking about. So can I cancel out that x plus 9 with one of the x plus 9s down here? Can I? Do you feel lucky? The answer is no, you can't. The reason you can't is because we have a subtraction there. If the entire numerator was a product, then yeah, you can. But alas, what we're going to do instead is just clean it up. So x plus 9. Upstairs, minus x minus 1, because we have to distribute through a negative, this guy, 1, all over x plus 9 quantity squared. Typically, for the quotient rule, you keep the denominator factored as it is. Just clean up the numerator. So you'll have 8, because the x's cancel, over x plus 9 quantity squared. Done. Now, here's the bad news. I got a little excited here because I love me some quotient rule. And for the rules we know so far in this section, we can't do part C. If that was just the square root of x, we could, but not a square root of x plus 1. Wah, wah. So come back later.